Hopefully you guys got the same thing, got everybody started on, got your testing done. So let's do a little poll here, A or B. All right, so A or B, would you rather live underground or inhabit an isolated mountaintop? I'd like to be on a mountaintop, but living underground might be cool too, because I could live somewhere where I could get to isolated cabin mountaintop. I might not be able to get stuff. Hey Keegan, good to see you. So most of you guys said live underground. All right, let's see what other people say. Oh, people want to go to the mountaintop for the most part. Okay, well, let's try another one. Start a poll. How about this one? Break into a stranger's home and stay for 2 days without them knowing. Stay outside for 6 days. Stay outside for 6 days. Okay. I'm not sure. Break into somebody's house. Stay outside for 6 days. What would you rather do? I need to stay inside. I think I would break into somebody's home if I needed to stay inside. What do you think? Not knowing outside for 6 days. I don't know. I mean, I don't know what kind of conditions the outside is. It's the difference, doesn't it? Thanks, George. Thanks, Jasmine. Thanks, Anella. All right, so most of you guys said number 2. Let's see. Stay outside. Oh, they said break into a stranger's house. One last one here. All right, so start a poll. All right, get a tattoo of a person you dislike on your back. Get a master's degree in the field you dislike. Oh, this one's going to stay with me forever. I don't know about the tattoo. At least a master's degree in something would be beneficial to you. I don't know. I mean, maybe if you found out like you got the tattoo, I mean, you liked him at first. I don't know. Most of you guys say, hey, good to see you. All right, so those who said 3, get a master's degree. Oh, you guys were right on. Okay. So what we're going to do today, So what we're going to do today is more of getting ready for the chapter test on thermal energy. There is a look at exit quiz. All right, many of you already took week 12 assignment 1, which is a lot of vocabulary, and week 12 assignment 2 is a lot of vocabulary too. There's a lot of vocabulary in this. So let's get started on going over kinetic and potential energies. Seem to confuse a lot of people, right? Confused a lot of people. And let's do this again, because I noticed when I took the last chapter test on that, I had to give people a lot of hints. If you looked at the chapter or the quiz from week 11, they had only 6 questions, and if you haven't taken it, I give you some suggestions of how to figure those questions out. All right. So if you can get into this energy skate park assignment here, just talks about potential and kinetic energy and the relationship between the two. Good to see you, Eli. Nice to see you. I haven't seen you in forever. Miss you much. All right, if you guys can get in there. Rainey, thanks for the heads up on that assignment. Boy, I just copied and pasted the wrong word in there. So no, you were the only one that figured it out. But I thank you so much for browsing and helping me correct my mistakes. There's Eli. Anybody else going to get in there? All right, so let's get started here. Okay. Oh, no. Yeah, that's okay, Janaya. I was happy that you made it in here. So happy. All right, so let's take a look at the energy diagram here, okay? So if we look at this, I put the skater up there, right? All potential energy, right? You can see the blue bar, And it's the same as the total energy. So the total energy doesn't change as I go. Okay, so if I let it go, start, pause, up. So gaining kinetic energy as we go down, almost no potential energy. And I can't for some reason stop at the bottom. Boop, boop, boop. But if I do this, okay, I can do this. So here is 50-50, right? Here is 100% kinetic energy because that's the highest speed, 0 potential energy. And notice the total energy bar doesn't change, right? So let's kind of go over that real quickly here in this slide presentation. So we've seen this slide presentation before, but it's always good to review. So let me put this in the slide projector mode here. All right. So you should have some or most an idea of how to understand kinetic and potential energy. If you don't, then make sure you see me this afternoon or this morning after halfway through the class. So at about 12 minutes. Right. So we look at this pendulum, right? The weight on the string from a fixed point. So it's a combination, it's mechanical energy. The energy transforms from potential energy, where height is in there, to kinetic energy where there's speed. So transforming. All right, so let me ask you this question. Let's see what you, I'm going to start a question, A, B, or C. So this is poll question 1. Poll 1. Poll 1. Okay, where is the greatest kinetic energy on this? All right, where is this? Poll 1 is a KE question. Where is the greatest kinetic energy? Where is, okay, I'm going to do this anonymously. Okay, so you guys can put in your vote there. So you can feel free to put in and not feel like you're subject to having somebody take a look if you got it wrong. So the greatest potential, greatest kinetic energy, right? Where is it is fastest? Okay, where is it? It's fastest. Okay, so I've got 4 people out of 10, right? 4 people out of 10. So 40% of you. All right, so I don't know who's not going to do that. Hey, Caitlin, how are you? And they see, who else did I not say hello to? I've said hello to everybody. So if we publish this poll, it's most people said the top one, but the answer here is the bottom. That's where the speed is. Now, again, if I ask where the greatest for the potential energy, which is my next question, right? Where is that one? Let's publish a poll and start. This is kinetic energy. Start a poll. This is number 2. Where is the greatest potential energy? And so what we're going to talk about here is where the greatest height is, right? Greatest potential energy. Remember, potential energy is gravity times mass times height. So if the mass is bigger, it's also there. So where is the greatest potential energy? So look for the height there. For the height, where is it? At the top, the middle, or the bottom? So we already know the greatest kinetic energy is at the bottom where the speed is, but where is the greatest potential energy? All right, so I got 4 out of 6 again. Thank you guys. And you're right, it is the top because that's the height, right? That is the height. Okay, so kinetic energy is converted, right? And again, like what we were seeing here, I'm going to move on to this next. All right, so if we see this, can you move, please? Go, move, move, move. Why can't you move? All right. Okay, so I guess I have to go back one. No, I think that'll be fine here. So as we look at the swing of the pendulum here, right? That is the highest it gets right here. So that is why we only have potential energy. We have the kinetic energy over here is very little. And as we come down, we gain potential energy and we lose height. So we lose this, we got chopped off, and then halfway we got a bar that looks like this. Okay, so let's talk about that a little bit more. So we talked about Tony Hawk, who's now in his 50s, so he doesn't do as much as he used to do. So at the top of the ramp, the skater has the highest potential energy. So we see this, and then the kinetic energy over here is 0, right? You can see that kinetic energy has nothing there. So there is no kinetic energy, and the total energy, if I draw a picture here, right? So let's make this in green. So if I have the total energy right here, okay, remember the total energy is the combination of the KE and the PE, and it's always 100%, okay? They're just switching back and forth. So it doesn't change its size. The total energy, it would change its size if we allowed for friction. We're kind of doing an isolated system here. So that is 100 to 0, right? Potential energy and kinetic energy. Over here, we still have our total energy of 100, right? But now we have kinetic energy is 20 and potential energy is 80. So adds up to 100. So as we lose height, this comes down. So, and then this goes up. So if we lose, just go to 60%, this has to come to 40%. All right. So as we continue farther down the ramp, you can see that we have 60, 40, right? Here's the 60 potential energy, and we haven't got to the bottom of the ramp. So when we get to the bottom of the ramp, we'll have all the potential, all the kinetic energy will go up, and the potential energy will be down to 0. So again, we're getting closer. Potential energy is going down. So this is a 60 for kinetic. So we're gaining some speed, and 40, we're losing some height. All right. And then again, we're at decreased. Now we have 20 potential energy, almost at the bottom of the hill, and 80. So they kind of switch places as we get closer to the bottom. And at the bottom, we will have 0. 0 potential energy because we have no height, and 100% or 100 joules here. Okay. So let's take a look at this question here. All right. So I'm going to ask you this question. We're going to start a new poll. Start a poll. All right. Start a poll. Let's publish this poll first. All right, so this is poll question 3. So this is going to be a answer. Let me start a poll here. Let's go here. Start a poll, and this one's going to have to be a typed response. So if the total energy of a closed system is 25, and we have a potential energy for of 5, so what's the kinetic energy going to be, right? Remember, this does not change. The total energy doesn't change. What we're going to do here. So whatever this is, so let me go question mark here, plus 5 has to equal the 25, right? Hey, got a couple people got it, right? Right, so kinetic energy is the highest. That means it's close to the bottom of the hill. If it was at the bottom of the hill, it would be all 25. Thanks for getting in there, ladies and gentlemen. So I got 3 people. Yeah, I usually get that in this particular case. All right, so yep, there's your answer, 20, 25. 20 and 5 give you 25. So how about this one? Start a poll, potential energy. Let's go poll number 3. Typed answer, start a poll. 40 for kinetic energy. So we're really close to the bottom of the hill. Right now I've got a total energy 50, so it's a different system. It probably has a heavier skateboarder, right? So what will this one be? All right, so remember 40 plus, let me go over here, plus this, the potential in it has to equal 50, right? All right, it's got the same 3 people. Maybe other people. Janaya, you had a question there. Oh, thanks, Janaya. Back there. Put it in the private chat if you want to. So it's 10, right? 40 plus 10. Okay. So let's go here. Let's see what we got. We got the answer here. Come on, answer. Put my plus 10, right? Okay. Do I need to move on? There we go. Move on. Yeah, 50 minus 40 is 10. Okay, so hopefully you got the idea on this. We've talked about it before. So energy transformations are every day. You know, again, potential and kinetic is goes on over and over again. If you're on the swings, so you can observe transformations in everyday life through chemical motion, chemical potential energy transformed to motion, and radiant energy changing to chemical energy in trees. So you can eat it, you know, if you have banana trees. Now we don't have banana trees in Michigan or Ohio. We have to get them from near the equator. But when we change that chemical energy into mechanical energy, that's our transformation. So basically what they're trying to say here is that energy is not lost. It gets transformed into different types of energy. So in summary, the law of conservation of energy states that energy cannot be created or destroyed. Energy can be transferred between objects or transformed from one form to another. Because of this, the total amount of energy in the closed system increases or never increases or decreases. So again, some of it gets lost, right? Lost to heat. Car engines, terrible. The old light bulbs that we used to have before LED were terrible. They were terrible for light because they were mostly just burning and creating heat. Now the LEDs are much more efficient, and they're better for light and less for heat. So if you want to have an outdoor cat and you make an outdoor space for them in an enclosure, you got to find an old light bulb to heat the shelter up, right? You don't want to put a new LED light bulb in there because it doesn't create enough heat. But if you put an old light bulb in there, like a 60-watt light bulb, it can keep your animal warm in the winter. So the cheap way of heating. All right. Which of the following describes how energy is transformed? Let's do this one. A, B, C, or D. Okay, start a poll. This one is conservation question. Conservation. All right, let's see how you guys are doing on this one. Energy is created during the process. Energy is destroyed during the process. Energy is converted from one form to another. Energy remains constant throughout the process. All right, what do you think? Start. Oh, I didn't do the start the poll. I did done. Start the poll. Anonymous on. There we go. All right, is it A, energy is created during the process? B, energy is destroyed during the process? C, energy is converted from one form to another? Or energy remains constant throughout? Got a lot of votes here. So energy is converted from one form to another, right here. Energy is converted from one form to another, right? From potential to kinetic, what we've been talking about, more than anything else. Thanks for getting in there, guys. 1, 2, 3. 4 people, and we got some new people in here. Who else did I get in here that I did not see come in? Oh, Jay, good to see you. Good to see you, Madison. Excellent. All right, so we are done for today, ladies and gentlemen.